My name is Michael Bentley. I'm a design director at AI SpaceFactory, and I'm here at the Architecture of the Future Festival to talk about the future of housing. So my company entered a competition with NASA in 2018 to do a 3D printed habitat on Mars. So this is basically the idea that to get to Mars, just because of the huge expense to get material off of Earth and to land on another planet, we need to find a way to build buildings in advance of astronauts landing. And the way to do that is using autonomous construction, so construction using robots, and also in situ resource utilization, so finding materials on the surface of the planet that we can use to do a 3D printed building. So we called our habitat Martia, and we won the competition by being able to demonstrate that we were able to print a 1/3 scale version of the habitat at the competition final. Now for us, in terms of the future of housing on this planet, a really interesting outcome was this material we developed. So NASA gave us choices in terms of what we can use. Concrete was one of them. But we thought, you know, water is so scarce on Mars, and also the atmosphere means it has a tendency to sublimate, so very difficult to control. So we thought, well, let's use a biopolymer, which you can create out of organic materials, and mix it with a basalt fiber, which you can find on the surface of Mars. And so we ended up creating this thermoplastic, which you basically heat and press out through the printer, which then cools in the form of the building. We developed this incredible material, which is actually stronger than concrete. It's also sustainable, it's recyclable, and it's also compostable. So at the end of the NASA print, we had this beautiful kind of 15-foot tall, 8-foot wide building. We thought, oh, this is sad. You know, it stood there for about 6 hours before they decided to knock it down. But we realized that we could actually grind it up into little pellets again and then reprint it. So that's what we're doing. We are printing an Earth version of the Mars habitat, which we've called Terra. We're doing this in Garrison, New York, and people can come and stay in it next year. So we basically have a user experience prototype where people can experience a vision for a way of building for the future of this planet, and also get a sense of what it might be like to be in a future space habitat. In terms of my history in the firm and a bit of our history as a practice, so we are almost 3 years old, but I think what's an interesting story for us is that we're an architectural startup with decades of experience designing very tall buildings, mainly in China. So the team that we have, the co-founders, I think are responsible for 4 or 5 of the world's top 10 tallest buildings. So personally, I began as an intern at the firm where we used to work on a project called the Shanghai World Financial Center, and then finally I worked on the Ping An Finance Center. So we have this experience of designing these very tall, skyscrapers. To my mind, they're kind of like the Formula One cars of the architecture world. They're very expensive, they're very high performance, and really spectacular. But we noticed that there was not really any great advance in construction technology. If you look at the 3 significant buildings, you know, kind of 400 meters, 500 meters, and then the Ping An Tower is 600 meters, you know, the height goes incrementally taller, but there was really no change in the construction technology. It's still a concrete core, you know, composite columns made of steel and reinforced concrete. But what was changing was the kind of the digital aspect of the building. So specifically the sensors. So in an early tower, let's say completed in around 2000, you have 100 sensors. 2005, 2010, maybe you have 1,000 sensors. In a tower like Ping An, you have 10,000 sensors. And so we wanted to be a part, I think, of that part of that challenge of integrating this new wave of digital technology into buildings, and finding a way for buildings to really respond in terms of their form and how they behave. So the first phase of our company, I think I would describe it as kind of exploring this kind of linking together of the digital and the physical, and you can see that in many of the projects that we did in China. And then as I said, a year ago, we saw the opportunity to enter the third phase of the NASA Centennial Challenge for the 3D printed Mars habitat. And so we entered that. I think that was a really transformative moment, because when we made the decision, as I mentioned, to go with a thermoplastic, to do a 3D printed plastic at this large scale, when we looked for a printing partner who could help us realize this, there was nobody who really had the expertise or the ability. And so, we kind of turned the traditional model of a designing architect partnering with, a 3D printing company or contractor. We kind of melded that together. So we, at that moment, turned ourselves into a design and build company. So when I say that we're a multi-planetary design and build agency, I can say that in all honesty, because we taught ourselves to 3D print, and now I think we're kind of pioneers of this new way of printing using sustainable materials, which I think really bodes well for the future of sustainable building on planet Earth. In terms of how AI SpaceFactory is using data in our designs and also in the spaces we design, I would say that in terms of the design process and the actual form of the Martia and the Terra structures, the data or the kind of computational technology is actually more in the construction and the design. So we're using kind of a manual process to model and kind of optimize the shell or the form of the building. So that's using a lot of experience, and I think the architect's eye and that kind of appreciation of the urgency of a human-centric design approach to space, which prioritizes kind of human emotion and is sensitive to human experience. I think where the computation comes in is then translating that form into something which can be understood by a 6-axis 3D printing robot, which has to convert that into a kind of a spiraling climbing pathway to basically deposit the print layers to then create a form that is structurally sound. In terms of using data inside our environments, I think that's a very interesting area of research. We do have sensors in our own office where we are basically monitoring the quality of the environment where we work. So for example, we're monitoring CO2 levels, temperature, humidity, and understanding how we work and how that correlates to the indoor environment. And then the offshoot of that is that we could look at ways that the environment, using digital technologies like lighting or temperature, could actually make adjustments to make it more optimal, which is great in terms of our own office. We also think that has a great significance for astronauts on future space missions. So for example, if you consider that the flight to Mars, I think, is 7 or 8 months long, and very quickly you would lose any view of space. So you'd just be traveling in kind of infinite darkness, great views of the stars, but not much else. It would be very lonely and very challenging, I think, for the human beings and the kind of human psychology of that mission. I think at that point, when you start to use computer like visual recognition and sensors to understand the mood or the health of the astronauts, and then be able to make a kind of adjustments to the environment, using lighting or temperature or augmented or virtual reality. So I think that's a very interesting opportunity, one that we're researching, and we're going to continue to kind of involve that digital and environmental aspect into the design as well as the construction. In terms of how AI SpaceFactory addresses the kind of a more human approach to space design, I think our building Martia was the first time where it was somebody actually proposed going vertically on the surface of a planet. I think frequently you see these like lunar habitats and Mars houses where things are domes or caverns, and people kind of hunker down against the elements as this kind of fear. And I think the Martia project was the first time where people actually, where we proposed standing kind of upright in a more proud way, more of a statement of our kind of intentions and of human ambition that can be seen, really on the horizon as a real kind of statement. that also had great benefits in terms of the efficiency of printing. So with a vertical print, with a 3D print, it's good to kind of minimize the kind of surface area of the foundation, and then it's very easy to go tall, and then you just kind of cap it with a skylight. So that's quite efficient, and also a very efficient pressure vessel. And then what that also does is it creates spaces, I think, which are great for people to live in. So we have 4 stories in Marsha. There's kind of a lab at the bottom for kind of missions that are coming and going from the habitat, kind of a kitchen and an experimental area on the 2nd floor, sleeping pods, and then finally under this kind of skylight oculus, which is letting in natural daylight and sunlight, there's a space for recreation. And then each of these levels would actually have a window looking out to the horizon, and because you're up, kind of 20 meters in the air, you would have great views over the Mars landscape. So I think all that kind of connection of human beings to each other and to their environment and to the natural rhythms of the Mars day are all important, and all things which we took into heart when we did the design. In terms of the delay of the construction industry taking up technology, I think it's many things. I think it's a huge industry. I think buildings are hugely expensive projects with a lot of risk involved, and so there's always maybe a fear of new technologies when you know that things can be guaranteed using an older method. But I think in terms of actually how the technology is used, a building site is not the same as a factory floor. So it's very easy to say, let's create an assembly line, to put together Teslas using robots. That's fine, but having robots arrive on a job site and then adapt to all those different parameters and unique conditions on a site, be it the geometry of the site, the weather, any kind of challenges. I think we're understanding that robotics and the sophistication of robots to be self-aware and to use, let's say, visual recognition to understand their surroundings and their location in a kind of three-dimensional matrix, still has a long way to go to make that a viable on-site technology. So I think in terms of the design industry, architects are great at using Rhino, BIM, and bringing that to the site. In terms of that really being translated into how things are built, I think it's just going to take time and investment and research to get there. I think we will, but I think it takes time.